All right. There we go.
She she met a guy at a gas station on Facebook Marketplace. He had a dog and took it home and kept it in the room.
Brother told me that she got a dog without telling your parents. And, like she was like,
How did they? Gas station. She could have got a dog. Yeah, he's a 50-year-old man. He was full time.
All right. Today we're talking about the mathematics of finance. Simple and compound interest. Interest compounded K times per year. Now, in most classes, it's N times per year. But this class, I decided to use different letters. Thank you very much. Interest compounded continuously, annual percentage yield, future value, and present value. Okay. Because this is stuff you actually use in life. All right. Joey Ray?
yeah. Every day in tech you teach us about.
All right. Interest. Regular interest. I equals PRT. Interest equals principal times rate times time. This is simple interest. Simple interest is I equals PRT. So the amount at the end of simple interest equals the principal plus the principal times the rate times the time. You'll actually have to know that for one of your problems. Okay? So that's simple interest. Okay? Now, when we're talking about compound interest, here's the compound interest formula, where P is your principal, R is your rate as a decimal, like if it's 6.5% interest, it's 0.065. Okay? And N is the number of times it's compounded. Okay? Or for N years. Okay? All right. So, suppose George Milligan invests $5,000 at 5% annual simple interest, and Quan Lee invests $5,000 at 5% annual compound interest. How much will each of them have after 10 years? Okay, simple interest. The amount equals the principal plus the principal times the rate times the time. Okay, so 5,000 plus 5,000 times 5%, so 0.05 times 10 years. Somebody, calculator. 5,000 plus 5,000 times 0.05 times 10. $7,500. Now, if we're doing compound interest, it would be principal times 1 plus the rate to the time power. Okay. So, principal is 5,000 times 1 plus 0.05 to the 10th power. Okay. If we do that, how much do we get? About $8,144, a difference of $644 just by the way the interest is taken versus from simple to compound. Okay, my numbers match their numbers. Isn't that so nice? Okay, or well, not my numbers, his numbers, but whatever, my formulas. So interest compounded K times per year. Now, interest isn't always compounded annually. Interest could be compounded quarterly, monthly, even daily. Okay? And then after that, even continuously. So, when we look at this, K is the number of times per year it's compounded. T is the number of years. Okay? So, a lot of times in the past, I've taught it A equals P times 1 plus R over N to the NT power. You may have seen that one before, but they changed their N's to K's. Okay? So, suppose Paul invests $400 at 8% annual interest compounded monthly, find the investment value after 5 years. So it's $400 times 1 plus 0.08 divided by how many months are there in a year? 12 to the 12 times 5 power. So it's 400 times 1 plus 0.08 divided by 12. I don't know what that is. To the 60th power. Okay? If we put that in our calculators and do the math, we get $595.94. Okay? So they made $195.94 on their investment. 8%, none of us are getting 8% in the bank, but hey, we might get 0.3%, but whatever. Okay, so this is compound interest. This is continuous interest. P equals E to the RT power. Okay, principal times Euler's number to the RT power. Okay, so you need to know those formulas. Okay, need to know those formulas. So compound continuously, A equals P E to the RT. Okay, all right. So let's say his same investment, as he had back here. Now it's compounded continuously. Let's see the difference. So 400 times e to the 0.08 times 5, or 400 times e to the 0.4 power. Okay? If we do that math, we get $596.73. Oh, he's a lot richer, like by a whole dollar richer. But if you're talking a lot more money, let's say it's 400,000, then you're $100 or $1,000. Yeah, whatever. He's richer. All right, annual percentage yield, which is kind of confusing. Annual percentage yield is advertised a lot when they're advertising CD rates and so on. So you have to understand what they're talking about. That's a percentage rate that compounded annually would yield the same as if it's compounded monthly or daily or whatever. So we want to figure out the APY if this is invested compounded monthly. So the APY, we take the 1,500 times 1 plus the rate equals, because this is 1 year, 1,500 times 1 plus 0.0625 divided by 12 to the 12th power. Okay, that's how we set it up. So we can divide by 1,500 right away, and that disappears. Okay, so 1 plus r is equal to whatever this number is. Somebody calculate out that number. 0.0625 divided by 12 plus 1. Take that to the 12th power. Shouldn't show up at 1. 1.064. Give me one more decimal. Okay, so if we subtract 1 from each side, the rate is 0.0643 or 6.43% annual yield. 6.43%. Okay. Future value of an annuity. Future value is how much money are you going to have in the future if you invest so much per month for so long. Okay. And present value of an annuity, this should say like a loan or a mortgage, is how much am I going to have to pay for like a $700,000 house per month if the interest rate is that and I put this much down and so on. Okay, These are real life things that you need to know. Okay? So Carlos purchases a pickup for $18,500. What are the monthly payments for a 4-year loan with $2,000 down if the annual interest rate APR is 2.9%? Okay, so this is a formula we need to use. All right, I'll try to write that down. PV equals R times 1 minus
Parentheses 1 plus I, parentheses to the negative n over I.
Okay. All right. So I is the interest rate. I stands for interest. Hey, that's a novel concept. The equal payments are R, and N is the number of payments that you're going to have. So the present value, if he purchases it for $18,500 and he puts $2,000 down payment on it, his present value is $16,500. We're trying to figure out what R is. Times 1 minus 1 plus 0.029 to the negative monthly payments, number of equal payments. So 4 years for monthly payments, it would be the negative 48th power divided by 0.029. Okay? So if you calculate that out, this is how it looks. Okay? Oh, 0.029 divided by 12. Sorry. So then what we do is we multiply each side by the denominator. I would figure this out as a decimal and then divide it. And so he has to pay basically $364.49 per month for that vehicle. $364.49 per month. Now, if you actually took that times 12, somebody take that times 12 once. $364.49. What we get?
4,373.8.
Oh, shoot. And then take that times 4. Should have taken it times 48 because there's 48 months for this loan.
17,495.52.
So, if you can remember, it was 16,500 was the amount they basically loaned him because it was $2,000 down. So if we subtract $16,500 from this, basically he's paying 995 or 900 and 495. Actually, it's a little over 1,000. Wait. 904.48. That's how much extra he's paying just by getting the loan, just on the interest amount. Okay? That's just his interest that he's paying. Okay? Are we good? Okay. So we're going to look at a couple of the problems you'll be doing. Discard. Go to here. Okay, I think everybody can handle these. Compounded annually, compound interest formula, just plug it in. Okay, so for the compound interest formula, the amount equals the principal times 1 plus the rate divided by the number of times it's compounded per year to the number of times is, or to the TK power, the number of years times the number of times compounded per year. Okay? So, simple interest is the amount equals P plus PRT. Okay? So make sure you use those formulas accordingly. Okay. Present value of a loan. So that's what we just got done doing. Okay. On that last problem. So present value of a loan is, I think I have the formula down here somewhere. Nope, didn't have the, so make sure you have that formula. Hopefully you have that formula. Jeez, I hate it when it does this. You get back where you're supposed to. All right. But the APR one tends to be a little confusing for some people. Okay. So how long does it take to double? And Mrs. Olson teaches about the rule 72. You just take the interest rate, you just take 72 divided by the interest rate, and you get the time it takes to double. But when you're dealing with APR, it's not exactly the same way. That same way. Okay? So what you have to do is figure out the rate once sorry. You have to figure out the rate once the actual interest rate and then divide. So APR is 1.076. Now I'm thinking what, okay, time it takes to double. Okay. So the APR is that. So time it would take to double would be like $2 versus $1 times 1 plus the interest rate, which is 0.076 divided by number of times 4 to the 4 times t power. Okay, we'll just do it this way. Okay, so if we divide each side by 1, that disappears. Okay, and then how do we get rid of this? How do we get it not so it's as an exponent? We can take the log of each side. Log of 2 equals 4t times the log of 1 plus 0.076 divided by 4. And then if we divide each side by 4 log of this stuff, you're going to get like 9.2 something. So it'll be 9 years and so many months. Well, 0.2 of a year, 2/10 of a year is close to how many months? Well, it's close to about 3 months. It's closest to 3 months versus anything else. Okay. All right. I'm just going to let you get going on these 10 problems. See how you do.